Okay, there's one more problem on normal distribution. 1,000 students have written an exam. The mean of the test is 35. Standard deviation is 5. Assuming distribution to be normal, find how many student marks lie between 25 and 40. Students get more than 40, students get below 20, students get more than 50. All the values that are being given to me are in terms of x. I convert it into the standard normal variate z. Okay. Let x denote the number of students. Denote the number of students. Students. Okay. So, what else is being given to me? Mean is being given to me as 35. Sigma is given to me as a 5. Okay. Right. Now, in the first case, what I will do in the first case, I'm being given two values, 25 and 40. Let x1 is equal to 25 and x2 is equal to 40. That's been given to me. Now, what will be z1? Just see. z1 would be what? x1 minus mu by sigma. Okay. Which is nothing but 25 minus 35 by sigma. x2 would be what? z2. I'm sorry. z2 would be what? x2 minus mu by sigma. z2 would be what? x2 minus mu by sigma. Okay, this would be what? 40 minus 20, 40 minus 35 by 5. Sigma here also is 5. Okay, these are z1 and z2 values. Now see here, what would be z1? 10 by 5 minus 10 by 5, which is nothing but minus 2. This is what? 5 by 5. Z2 is equal to 5 by 5, which is 1. So I can clearly see, always make it a point to draw the normal distribution curve roughly. Okay, so that you notate your points properly. Z1 is here. And you shade the region properly as well. Z2 is here. Z1 is negative. Z2 is positive. Now what's been asked? Probability of Z1 less than X1 less than or equal to. I'll write like this. I'll write properly. Just a second. Probability of x1 less than or equal to x less than or equal to x2 is being asked. In terms of z, it is z1 less than or equal to z less than or equal to z2. Okay. Now, what's that I need to find out? I need to find out the area between z1 and z2. This is like this. So, I'll write it like this. Just see. How is it? Probability of minus z1 less than or equal to z less than or equal to 0 plus area from 0 less than or equal to z less than or equal to z2. Just see here, the area from here to here and from here to here. And clearly, by symmetry, the first value would be nothing but 0 less than or equal to z less than or equal to z1. Okay, and this is 0 less than or equal to z less than or equal to z2. I should write here by symmetry. By symmetry, I'll be writing like this. Right, what's the value of z1? Write down. 0 less than or equal to z1 value, I've got it to be minus 2, or I'll be writing plus 2 because from 0 to z1, whatever is the area, 0 to minus z1 also is the same area, right? So P of 0 less than or equal to z less than or equal to 1. Look at the table for 2.00. See the area. It would be what? 0.4772 plus this would be 0.3415. From normal distribution tables, you will write like this. From normal distribution tables. Okay. So what will I get? The value to be as 0.8185 is the value. Okay. Area between Z minus Z1 and Z2. Let's come to the second question. What's been asked is, how many students get more than 40? What I'm asked is P of x greater than or equal to 40. Okay. Now, Z is equal to x minus mu by sigma What is x? 40. What is mean given to me is 35. By what is sigma given to me? 5, which is 1. Okay. So what exactly is being asked is P of z greater than or equal to 1 is being asked. Z1 or whatever. Okay, just see here. Again, you draw the curve, notate the point and then check for. This is my Z or 1. Z is equal to 1. What's been asked? Area above 1 is being asked. So this area. How do I find it, guys? How do I find this area? If you understand normal curve, it is very simple. How do I find it is from here to here, the right half from here to here, the area is what? 0.5. From which I will remove the area 0 to Z1. Okay, I'll be getting this part, this shaded part. Okay, so from 0.5, I'll be removing the area from 0 less than or equal to Z less than or equal to 1. I'll be getting that part, whatever has been asked in the question. Okay, so 1 already in the previous I have calculated for Z1 till 1 what is the area? 0.3415. So if I subtract it, I'll be getting 0.1585 to be the, this is from the table, from normal distribution table. You should write, you should make a mention whether it is symmetry or from it is from the normal distribution tables, you should write. Okay, so what I have got it to be is how many students get more than P of x greater than 40, greater than or greater than or equal to anything is fine. I've got the value to be what? 0.1585. How many students are there? This value for 1000 students, what does it symbolize? I will take 0.1585 gives me the number of students getting marks above 40. Okay, so what does this give me? Just how many students are there? 158.5. I can round this off to 159 as well. So 159 students are getting marks above 40. Here also you can check that, guys. Here in the previous A problem also you can check what's been there here. Yeah. So here what I'll do? Students how many marks? 25 and 40 would be what? 1000 into 0.8185, which would be 818.5. I can approximate it to 819. Okay, guys? Yeah, fine. Now coming to the third question. What's that? How many students get below 20? X less than 20, less than or equal to 20. It's a continuous distribution. So equal to or anything is fine. So yeah, I've already calculated Z is equal to, okay, not calculated. X minus mu by sigma, which is what? 20 minus 30 by 5. Okay, 35 by 5. This value would be what? Minus 15 by 5, which is equal to minus 3. Okay, so this is nothing but P of Z less than or equal to minus 3 is what I have to calculate. Just see here, if you put it under the curve, then things will turn out very easily. Minus 3 would be towards the left. What area I want? Less than or equal to minus 3 values would be somewhere here, right? So how will I find this area? This total area towards the left is 0.5, right? From which I'll be deducting this area from 0 to minus 3 to 0, okay? Look here, P of x less than 20 is nothing but P of z less than or equal to minus 3. This can be rewritten as from 0.5, I'll be removing the area from minus 3 less than or equal to z less than or equal to 0. This is same as minus P of 0 less than or equal to z less than or equal to 3. Okay. By symmetry of normal curve. Normal curve. Okay. So what I'll be getting is 0.5 minus this area. If I look into the normal distribution tables, is 0.499. This would be what? 0.001. This area would be nothing but 0.001 from the normal distribution tables. Here I will be writing from normal tables. Okay. Yeah. So 1000 into this, 1000 into 0.001. If I take only one student scores less than 20, one student scores less than 20 marks. Okay. From the question, that's the question that's been asked, right? Now for the final question, what I have is more than P of x greater than or equal to 50. This would be P of z greater than or equal to 50 minus 35. Z is equal to 50 minus 35 by 5. Again, it is 15 by 5, which is 3. Greater than or equal to 3. Draw the normal curve and see where it lies. Positive value, Z is equal to 3. So, this is the area I have to find out. How will I find it out? From 0.5, I will be removing the area from 0 less than or equal to Z less than or equal to 3, guys. And then I'll be getting the answer. And then the same thing, 0.001. Okay, this into 100, one student gets more than 1000 into 0.001 is equal to 1. Student gets greater than 50. Greater than 50. This is how I'll find. I'll convert things from a normal variate to standard normal variate Z and bring everything under the normal distribution curve and solve it like this using normal distribution tables, which makes my job easy. Okay.